Let n be a 5-digit number, and let q and r be the quotient and the remainder respectively when n is divided by 100. For how many values of n is q plus r divisible by 11? So the first value of n where this is going to be true is going to be 10,010. So when this is divided by 100, we get 1,100 remainder 10. So q is 100 and r is 10. So q plus r is equal to 110, and 110 divided by 11 is equal to 10. So it is divisible by 11. So 10,010 is the first value of n such that q plus r is divisible by 11. And it's going to be true that as long as the remainders increase by multiples 11, while q is still 100, then q plus r will be divisible by 11. So the same is going to be true if you have 10,021 divided by 100. That's just 10,010 plus 11. We're going to get 100 remainder 21, and 121 divided by 11 is just 11. And so while q is still 100, the values of n where q plus r is going to be divisible by 11 are going to be 10,010, 10,021, 10,032, all increasing by 11, all the way until you get to 10,099. Then the question is, what happens when the value of q changes? So we're always going up by 11 here. So what happens when the value of q changes is going to be this quotient is going to be 101. So what happens when we're dealing with the first value of n where the quotient is 101? Well, when the quotient is 101, in order for this to be the q plus r to be divisible by 11, we need the remainder to be 9. And the number where this is going to be true is just 100 times 101, which is 10,100, and then just add 9. So 10,109 is that first value there. So 10,109 is that. And so then from there, so looking at our list here, 10,109 is the next value. And then for values of q plus r from there that are divisible by 11, from there then we keep adding 11. So 10,120, 10,131, and this continues all the way until we get to 10,198. And then we get into this same situation where the quotient is going to be 102, and we want the remainder to be 8. So again, we keep, here it's plus 10, and then it keeps going plus 11, plus 11. And then from here, when the quotient switches over to 102, this is going to be 10,208. And these are all the values of n that will work here. It keeps continuing on. So erasing some of this. So looking at this list, we can see that so from 10,010 to 10,109, we've added 99, and the values of n such that q plus r is divisible by 11, it's going to be, we have 9 of them after this 10,010, plus including this 10,010, so plus 1, which is 10 values. Then we add, adding another 99 from here. now the total number of values of q plus r, it's going to be, we've added, there are then another 9 numbers from here. So 1, 2, 3, all the way down to 10,208. So it's 9 times 2 plus 1. And that plus 1 represents the 10,010. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 until we get to here. And then 9 until we get to here. So every time we add 99, we get 9 more values of n, such that q plus r is divisible by 11. So that's 19. So basically, we just want to find, if we can find the largest value of n, then we can figure out how many values of n exist such that q plus r is divisible by 11. So in order to do that, so we have 10,010 plus, since we're going by 99s, 99 times 900 is 99,110, and then 99,110 plus 99 times 8 is 99,902. And so it's true that 10,010 plus so why does this matter to us? Well, we found that every time we add 99, we get 9 more values of n such that q plus r is divisible by 11. Therefore, that since we're going, each time we're adding 99, we're doing that 908 times. Then when we get up to 99,902, we have 9 times 908. And remember, we have to add this plus 1 because it's 9. Every time we go up by 99, it's 9 more values of n, excluding this one. So it's 9 times 908 plus 1. It's 8,173 values of n, where q plus r is divisible by 11. We're not quite at the largest 5-digit number here. The way we figure out the remaining values of n are going to be, how many times can we add 11 to this? And it's going to be true that we can add 11 8 times, and we get 99,990. And if we add 11 again, we're going to get a 6-digit number. So this is the largest value of n. And we've added 11 8 times. So therefore, there are 8 more values of n. Where q plus r is divisible by 11. And so we have this 8,173, and there are 8 more values of n. So 8,173 plus 8 is 8,181 values of n, where q plus r is divisible by 11, and that is our answer. So the answer is choice B.